Hello, in this video I will do a demonstration on how to compute correlation coefficients and their 95% confidence intervals using R. So here correlation coefficients include the Pearson correlation coefficient and it's a non-parametric version, the Spearman's rule. Okay. So first let's set a random seed for reproducibility. Sample size 100, X is a random sample from the standard normal distribution. Y is 0.5 times X plus another random sample from the standard normal distribution. So X and Y are related. When you are computing correlation coefficients, it's always good to plot out the scatter plot to visualize their relationship. So here you can see from the scatter plot, X and Y are somewhat related, but not very strongly. Okay. So to calculate the Pearson correlation coefficient, you simply use the core function. So the syntax is the core X and Y method equal to Pearson, and you can print out the Pearson correlation coefficient. So here is 0.53. Okay. And also you can calculate Spearman's rule, which you use the same function core. And the only difference is the method equal to a Spearman. And you can print out the Spearman's rule, which is 0.48. Okay. And then we can also perform a hypothesis test. The null hypothesis is whether the true correlation is 0 or not, okay, or 0. So we can test the Pearson correlation coefficient, and we can use the core.test function and specify method equal to Pearson. Okay. And then we can actually print out its p-value. And here the p-value is very small. It's 1.2 times 10 to the negative 8. Okay. And similarly, we can calculate the p-value from the hypothesis test, the Spearman's test, for testing whether the true Spearman's rule is 0. And you use the same function core.test, and the option is method equals Spearman, and you can calculate the p-value from that, and it's also very small. So both p-value tells you the Pearson correlation coefficient, the true correlation, and the true Spearman's rule are not 0. And if you want the confidence interval, they actually they come with the object of the Pearson test. For example, for the Pearson correlation coefficient, we can just use the object for the Pearson underscore test, then $conf.int. This gives us the confidence interval, the 95% confidence interval for the Pearson correlation. But unfortunately, for the Spearman's rule, the calculation of its 95% confidence interval is not straightforward. So we're not going to show it here, but there is an R package we can use to do that. It's covered in another video. I can provide a link in the comment area for that. Now the second part of this video is really showing you how sensitive the Pearson correlation is to even like just one outlier. Okay, so here we can add one pair of outliers. For example, we know X and Y are there from like mean 0 and with standard deviation 1. But we add, say, 10 to X and negative 10 to Y. So 10 and negative 10 way out of the normal range of the range of X and Y. So we can again plot out the scatter plot. Now you can look at the original data set is all the way to the upper left, and the outlier we added is all the way to the like lower right. Okay. And if we go ahead and calculate the Pearson correlation coefficient print it out, you can see now it went from a positive correlation to a negative correlation. So even by adding one outlier to the data set, the correlation changed the direction. Okay? And if we, that just shows how sensitive Pearson correlation coefficient is toward outliers. Okay? So, but if we do the same calculation using the new x and y for the Spearman's rho, we can see it's still about the same. I think the original Spearman's rho is 0.48, but here is a 0.44. So it really did not change much. And this is because Spearman's rho is a non-parametric statistic. It's not sensitive to outliers. Okay. And this also tells us that when you compute Pearson's correlation, it's a good idea for you to also compute Spearman's rho and just make sure you can see the influence of outliers if they exist there. Okay. And then we can also calculate the Pearson's test. And now you can see the hypothesis test have a different result. The true correlation is not significantly different from 0 based on this test with the new outlier added to the data set. So it also changes the inference. Okay. Yeah, but we can also try this. To do the test for the Spearman rho, and it's also not sensitive to outliers. The inferences remain the same. We reject the null hypothesis. Okay. And if we want to calculate the confidence interval for the Pearson correlation with the outlier, then you can see this interval with negative lower limit and positive upper limit. It's very different from the previous 95% confidence interval for the Pearson correlation coefficient without outliers. Okay, so this example just shows you how sensitive Pearson correlation is toward outliers. So it's always a good idea to compute both Pearson correlation coefficient and the Spearman's rho together so that you can capture outliers in the data set. Okay, thanks for watching, and I hope this is helpful.